Welcome or welcome back at C Square. In this lesson we will talk about rectangles, and you see here the definition of a rectangle. A rectangle is a parallelogram, that is very important, with four right angles. And here these first two statements tells you the shape we have in the picture is a parallelogram. We have two corresponding parallel sides, AB, parallel with CD. We can see that in the picture also. And AD parallel with BC. So that tells us we have a parallelogram which has one right angle. We see angle A. But of course, you remember, since this is a parallelogram, when we have parallel lines, all four angles are going to be right angles for different reasons, right? And that is the definition of a rectangle. Now, because a rectangle is a special parallelogram, yes, it's a parallelogram, we have the same property as the parallelogram, which we see them right here. This one, sorry, try to do a better job. This 1, 2, 3, 4. These four belongs to the parallelogram. Opposite sides are parallel and congruent. Opposite angles are congruent, 90 degree in this case. Consecutive angles are supplementary, each one 90. Diagonal bisect each other. So as I said, these are the property of the parallelogram. And this is the definition of a rectangle. All angles are right angle. And this is the extra property that goes with rectangles. Diagonals are congruent. Remember, for a parallelogram, the diagonals are not congruent. So now let's see some example here, and we'll look to the first one. We have here use, and if you see this sign like this, it's look like a rectangle. It means rectangle A, B, C, D, and answer part A through D. And on part A, we are asked how much is AB, how long is this segment AB. And if you notice, this AB should be the same of DC. I marked them the same because they are congruent. Why? This is one of the property of a rectangle or parallelogram. It works on both. Now let's take a look to part B. Part B, we are asked how long is this segment DB. And if you remember, this one is 12. So for part B, you may want to draw this triangle, which is the bottom half of the rectangle, is the triangle ADB, which is a right triangle. Remember, this is a rectangle, so all the angles are 90 degree. This is 5. This is 12, and we need to find these guys. And if you do not know the Pythagorean triplets, then you have to use the Pythagorean theorem, which I'm gonna do it in a moment. That Pythagorean theorem says a squared plus b squared equals c squared, which means 5 squared plus 12 squared. Those a and b's are the legs, 5 and 12, equal x squared. So 5 squared is 25, 12 squared is 144, and that will be x squared here. We have x squared equals 169. We can switch that to equality, and then for finding x, we just do square root of 169, and that will be just 13. Remember that x is nothing else than dB. dB will be 13. It's good if you remember this Pythagorean triple. 5, 12, 13 is one that I do remember beside 3, 4, and 5. Okay, now let's go to part C and D. And in part C, we are asked the measure of angle DBA. DBA, so is this angle. And this angle here will be the same of this one, 27. Why? because these two angles are alternate interior angles. DC and AB are parallel lines, right? And those two angles are alternate interior angles. So the measure of angle DBA, it's 27 degrees. I'm gonna put here the reason, in case you need it, alternate interior angles. Oh, let me in fact put that statement. Angle CDB congruent to angle ABD or DBA. It's the same thing. Okay, and that's the reason we have the same measure. And let's go to the last part, part D. We need to find the measure of angle DBC. This is this angle. And that angle will be what? That one will be 90 minus 27, which will be 63 degree. The reason is these two angle DBA and DBC, these two angles, they are complementary. Right? They form that 90-degree angle. So that's the reason that statement works. This angle here, I'm going to make this big square. This is 90 degree. Okay. My second example in this lesson here, we have a rectangle. The picture is not given to us, but you may want to draw a picture. LMNP is a rectangle, and we need to find the value of x and the length of each diagonal. If Ln is 3x plus 1 and NP is 3x plus 4. So I will suggest you, let's make a picture. We don't really need it, but sometimes it helps, especially if you don't know what you need to do. Let's say this is a rectangle. I know it doesn't really look like, but it is a rectangle. L, M, N, P. So this is L. Okay, rectangle. So if you remember, these two are parallels, these two are parallels, and we have 4 right angles, so we can just mark 1. Okay, so this is a rectangle. You don't really have to be that accurate. But now we need to know what Ln, which is this diagonal, it's 3x plus 1, and MP, which is this diagonal, is 3x plus 4. What do we know about these two diagonals? We know that these two diagonals are congruent. This is the property that is specific to a rectangle. It also works for square also, but in this case, let's stop here. This is the property I'm going to use. The diagonal of rectangles are congruent, which means they have the same measure, which means I'm going to write this statement here, 3x plus 1, and I think here we have a problem. 3x plus 1 equal 4x. Let's make it 4x here. And minus 4. So let's do that here, because other than that, this one will not work. Okay, 4x minus 4. Okay, so now we need to solve this problem. I'm going to subtract 3x here to find x. We have 1 equals x minus 4, and add the 4. And we end up with x equals 5, which is the first part of the problem. And now we need to find the length of each diagonal. So we're going to plug in one of them, let's say in ln. ln is 3x plus 1. This is the good one. I apologize for the second part. So that will be 3 times 5 plus 1, and that will be 15 plus 1, and that will be 16. So the diagonal ln is 16. Obviously MP will be also 16 because they are congruent. Okay, of course you can plug that 5 in the second expression, this one, and you'll see you get the same 16. Let's move to the next example. Very similar. Now we do have a picture. Find the value of x if RSTW is a parallelogram. Justify your angles. Oh, so we know this is a parallelogram. But also, what do you notice in the picture? We notice the right angle here. So in fact, what can I say here? I can say, in fact, I can identify this parallelogram better. This is a rectangle. Okay. So what do we know about a rectangle? We know a bunch of things, but we're looking now here. RZ, it's this guy. And SW, look at here, what I'm going to do, it's these two pieces, which are the same of RZ. Okay. In fact, let me say this, RT is congruent with SW. This is the property that belongs to a rectangle. The diagonals are congruent, which means the segment RT and the segment SW have the same measure. But if we take a look, RT is nothing else than twice RZ. You see, I marked them the same thing here. Twice RZ equals, and I'm gonna keep this SW. Why? Because that's what we have here, if you notice. So I'm gonna have twice 2x plus 5 equals 5x minus 20. So this is the equation that is the result of the fact that we have a rectangle. And now distributive property here. So I'm going to move here, and we're going to have 4x plus 10 equal 5x minus 20. And I'm going to subtract 4x here to cancel this 4x. Obviously, you have to do the same thing on the other side. So we have 10 equals x minus 20. And then add 20 on each side. And we have x equals 30. Okay, and that's it for this problem. And the justification is right here on the right side when I said this is a rectangle and the diagonals are congruent. Now let's take a look to my next example where we have a rectangle. Now we know it is a rectangle. Find the value of x and y if the measure of angle TMN, this one, it's 3x plus 20, and the measure of angles RTP, this guy here. I'm gonna mark it different because these angles are not the same. It's 4y plus 8. and the measure of angle TNP, measure of angle TNP, this angle here. So now, what do you think about this angle? Is it equal of any of these? No, it's not. We were discussing amount. I'll mark it like this, is 56. So we need to find the value of x and y. Let's take a look to this picture, and this angle here, since we start with this, is going to be congruent with this one. And why? Because remember, this is a rectangle, which means these two are congruent. Diagonal bisect each other and they are congruent. So all these four pieces are congruent. So we have, in other words, four isosceles triangles. So those two angles are congruent. These two angles, this one and the other one, are congruent. So a bunch of congruent angles. But now if we take a look here, the sum of these two angles is going to be 90 degrees, because you remember each angle of the rectangle is 90 degrees. So that's going to be my first statement here. The measure of angle MNR plus the measure of angle PNR is 90 degrees. Now, how much is the measure of angle MNR? It's the same with the angle TMN, 3x plus 20. How much is the measure of angle PNR? It's the same with this guy, TNP, right? And that will be 56 equals 90 degrees. And so now we have an equation in x. So the first thing I'm gonna combine these two guys, and that will be 76 equals 90. From here it's a two-step equation. Subtract 76 on both sides, and we have here 3x equals 14. And divide by 3, so we end up with a not very friendly answer, but it's not a bad one. 14 over 3. So we have x. Now the question is how we find y. And why you have so many choices, but I think we can do something very cool. If you know, let me erase the picture here. We have too many things here, right? And I'm gonna keep just these three angles. Okay, and if you remember, TNP is this guy, which is 56. This is 56. The question is, how can I use to find this angle now? And that, if you notice, is an exterior angle for triangle TNP. So that exterior angle will be the sum of the measure of the remote interior angles, which are these two guys. So that's my thing I'm going to write here. The measure of angle RTP equals with the measure of angle TNP plus the measure of angle NPT. So what I use here is the exterior angle theorem of a triangle. Exterior angle of a theorem of a triangle, right? So we have here RTP, it's for y plus 8. TNP is at 56. And the other one, it's also 56. So we have here 4y plus 8 equals 56 plus 56, that would be 112. I'm going to subtract 8 to get rid of this 8. So I have 4y equals 104. And the last thing, we're going to divide by 4. And we have here 104 over 4, which will be what, 52 over 2. If we simplify by 2, and you can also divide one more time by 2, so it's going to be 26. And that is about this example. And now in my last problem, we're going to look to how to apply coordinate grid about problem involving rectangles. And for that reason, you can use these formulas: distance formula, you see it here, the slope formula, and the midpoint formula. These three formulas can help you for solving problem like this one. Quadrilateral ABCD has vertices 1A, 1 and 2, B, 3 and 5, C, 9 and 1, D, 7 and -2. Determine whether ABCD is a rectangle. So how are you going to do this? Obviously, one way to do it is to look to the diagonals of this rectangle, AC and BC, and you can find how long they are, and if they are congruent, if they have the same length, then we have a rectangle. That is the property of a rectangle. So if AC will be congruent with BC, then ABCD is a rectangle. That will be one way. Now, some people may know, okay, can it be something else besides a rectangle? Yeah, it can be a square, but so far we talk about rectangle here. Okay. But my first piece of advice will be, especially if the numbers are manageable, like this one. These numbers are manageable. You can plot them, you can graph them like I did here, right? A, 1 and 2, B, 3 and 5, C, 9 and 1, D, 7 and -2. Do you notice the picture can help you, help me, help us to solve this problem? Why? We're going to take a look to a different way now. I'm not going to do that property of the rectangle. I'm going to look to the slope of AB, for example. I mean, we're going to start with AB, this side. And this one we can count, right? Do you notice we have this rise of 3, run of 2. The line goes up from left to right, so it's positive 3/2. Then we can look to DC, this guy, and we notice we have the same type of thing. So we're gonna have 3/2. So what do we know right away? We know AB is parallel with DC. And very similar we can do for AD and BD. They're gonna be the same. So that's the reason I'm gonna just write one long statement. The slope of AD will be equal with the slope of BC. And let's see how much it is. 1, 2, 3, 4, 4, and 1, 2, 3, 4, 5, 6. 4 over 6, but remember it goes down from left to right, so it's gonna be -2/3. So now we know that AD is parallel with BC. So from these two statements, what can we say? We can really say ABCD is a parallelogram. Don't say it's a rectangle yet. Okay, we know it's a parallelogram because we have two pairs of opposite sides parallel. So what else we need to know to be sure it's a rectangle? We need to find the right angles. So now, do you notice this is negative 2/3, this is 3/2? So if I'm looking, for example, to the slope of AB, the one we start with, it's 3/2, and the slope of AD, negative 2/3, they are negative reciprocals. So that means AB, it's perpendicular on AD, which means angle A, it's a right angle. So now we really know, based on the fact that we have a parallelogram of a right angle, we know A, B, C, D is a rectangle. And you see, this one is a kind of a coordinate proof using this slope formula. Of course, like I said, you can use the distance formula, and you will notice AC will be congruent to BD. I should have said here BD, not BC. Okay, and that will be another way to prove this is a rectangle. You could have used the midpoint formula and find all the segments are congruent. I think that would be a long way. And that's it for today's lesson. If you enjoyed today's lesson, don't forget to click the like button and come back on CE Squared for more help. Thank you.